Hello friends, welcome to Risingpearl.com. Today we are talking about series 8 where we have been learning a whole lot of stuff on arithmetic progression. Friends, this is webisode number 13 and today we are going to continue to find out how do we solve questions where we may need to calculate the sum of n number of terms of a arithmetic progression. This is part 9 because we already have covered 8 parts, 8 episodes dedicated towards finding out what kind of questions we can get on arithmetic progression, but most importantly, how we go about solving those questions. So I really hope, friends, you're following us along at risingpearl.com. For any reason, if you have not got a chance to take a look at those videos, I would suggest whenever you get a moment, please take a look at those webisodes where we really have taken great amount of time to go through, really identify all different kinds of questions that you may get, from simple questions to a little bit more complex questions to really some of the tough questions on arithmetic progression and how we go about solving them. So let's take a look at some more types of questions, more flavors of questions in this webisode. So our question number 33, as you know, this is a running count of all questions that we have covered. Show that a1, a2, dot dot dot, an dot dot dot, they form an arithmetic progression where an is defined as, this should be n as in subscript like here. So the an is given as 9 minus 5n. So let's take a moment and understand what the question is really saying. So show that a1, a2, dot dot dot, an, these are terms of arithmetic progression. Show that there is an arithmetic progression where the nth term is defined as this. So how are we going to do this? So what is given is that an, or the nth term, is given by this formula 9 minus 5n, and we have to say that, show that this is actually really arithmetic progression. So how do we do it? So what we are going to say is, we are going to say, okay, fine, so when we put n equal to 1, that will be the first term, right? So for n equal to 1, a1 will be 9 minus 5 times 1, because we are putting n equal to 1. So we get 9 minus 5 ones are 5, or 9 minus 5 is 4. So we say, alright, so the first term is 4. Then let's take a look at n equal to 2. Then that will be the second term. So again we are going to put n equal to 2 in this formula, right? This is the formula that tells us all the terms. That is what is given in the question. So simply putting n equal to 2 here, we get 9 minus 5 times 2. So we have 9 minus 5 2s are 10. So this is minus 1. Alright, let's do n equals 3. So that will be the third term. So here we have 9 minus 5 times 3. So we have 9 minus 5 3s are 15. So this will be equal to minus 6. So at this point we can pause and we can see, let's do a2 minus a1. If we do a2 minus a1, we get a2 is minus 1. This is minus 1. So a2 is minus 1. a2 minus a1. What is a1? a1 is 4. So this will be minus 1 minus 4. This will be minus 5. Okay, let's now do a3 minus a2. So what we are doing, friends, is, as you can imagine, so we have the terms a1, a2, a3, a4, so on and so forth, right, in any arithmetic progression. So we are trying to find out the difference between these two consecutive terms, a2 minus a1, and then we are trying to find out the difference between a3 and a2. So a3 minus a2, what is a3? a3 is this term, minus 6. So let's write minus 6 minus, what is a2? That is minus 1. Minus 1. Make sure whenever you have negative of negative that you really put them in the square bracket, and you don't want to miss out the fact that the term a2 itself is minus 1, right? So when you remove the bracket, you will get minus 6. Minus minus will become plus 1. And this one will be minus 6 plus 1 is minus 5. So what we see indeed is that a2 minus A1 is equal to A3 minus A2, which is something which absolutely is true for arithmetic progression. So we say indeed this series or these numbers where the nth term is represented as an equals n minus 5n is indeed a arithmetic progression. So now that we have found out this is arithmetic progression, what about the second part? Find the sum of first n number of terms. So now at this point, so we have, let's see what we have. The first term is 4, right? And the common difference is minus 5. So at this point, friends, this is a pretty straightforward question. Let's give ourselves more space. So what we have is our first term, which is a, is equal to 4. And we have our common difference is equal to minus 5. And we have to find out the sum of first 15 terms. So where n is equal to 15, so how are we going to find it? So quite simply, sum of the first 15 terms will be simply equal to n by 2 times twice a plus n minus 1 times d. Let's just put the values in here. So n equals 15 by 2 times 2 times a is 4 plus n minus 1, n is 15, minus 1 times d is minus 5. So this is what we have. If we keep solving this, so we have 15 by 2. I'm not trying to make it 7.5 because I'm trying to see if this 2 will cancel out something else on the top. So 15 by 2. So 2 4s are 8. Now plus, but we have minus. So this will be 14 times minus 5. So that will be minus 14 5s are 70. Or in other words, so this will be a negative number, minus. So we have 15 times. So if we actually solve this, this will be minus 62, right? This will be minus 62. So the minus comes here. So 62 times 2, and then this will be 31. So the answer is, it is minus 15 times 31. So whatever this value is, and I'm not going to actually calculate this, I'm absolutely sure you guys are smart enough. You guys and girls are smart enough to figure this out. So whatever the value is the sum of first 15 terms of the arithmetic progression where the nth term is given by this formula. So if you get this kind of questions in your exams, this is how you're going to approach and solve these kinds of questions. Let's take a look at one more question. Find the sum of the first 40 positive integers which are divisible by 6. We have done something similar, I think it was a few episodes ago. So I just wanted to refresh because these kinds of questions, it's hard to relate that why are these questions connected with arithmetic progression. On the surface, they do not look like they are arithmetic progression questions. So let's take a look. So find the sum of first 40 positive integers divisible by 6, right? So the first positive number which is divisible by 6 is, well, it is 6, right? The next one is 12. Then we have 18, right? So how do we get these numbers? It is basically simply 6 times 1, 6 times 2. This is how we are getting these numbers, right? So it kind of goes on like this. So what we have to do, the question is saying find the sum. So we have to find out the sum of these numbers. But how many of them? We have to find out up to 40. There are 40 numbers or 40 terms. So this series, or this arithmetic progression, 6, 12, 30, 6, 12, 18, like this, for the first 40 terms we have to find out that sum. So how can we do this? Well, clearly we know that a, or the first term, is 6, right? We also know that the common difference will be 12 minus 6, which will be, let's write it, 12 minus 6. So the common difference is also 6. And the number of terms for which we want to find the sum is 40. So let's see. So we know that this is given by the formula n by 2 times 2a plus n minus 1 times d. So we need to know n. Do we know n? Of course we know n because n is 40. A, the first term, do we know the first term? Yes, we know the first term, which is 6. And d, do we know d? Of course, d is 6. So simply by putting these values, so n equals 40, let's put this here, 40 by 2 times twice a. So 2 times a is 6 plus n minus 1. N is 40 minus 1 times d is 6. So what we are going to do is, just to make it a little bit easier, from here we are going to take the 6 common outside. So we will have 40 times 6 divided by 2. If we take 6 common from here, so we will be left with 2 plus 6 will go out. It will be 40 minus 1, 39. Or in other words, now we can simply actually cancel this out. So 220, so 40. So we have 20 times this 6 times this will be 41. 39 plus 2 is 41. So again, if you just simply find out what this value is, and obviously you are going to do 6 2s are 12, so you are going to actually multiply 41 times 12, and whatever you get, you're going to put a 0 at the end. So this will be the product, and that will give you the sum of first 40 terms of first 40 positive integers which are divisible by 6. So what was important in this question was to realize that when the question is given as find the sum of first certain number of positive integers which are divisible by 6, the fact that these numbers which are divisible by 6 or 4, 3 or any other number, they actually form an arithmetic progression, right? Because the numbers which are divisible by 6 in this case, the way we are going to find this number is 6 times 1, 6 times 2, 6 times 3, like that. So the first number is 6, then we get 12, then we get 18, up to 40 terms. So essentially, if you look at this, that means this is an arithmetic progression. This is the first term, common difference is 6, and then how many terms we need, of which we have to find the sum of, that is 40 terms. So if we have the value of A, if we have value of D, and if we have N, we can absolutely find out the sum of first N number of terms. Let's take a look, maybe one more question. Find the sum of first 15 multiples of 8. So again, I think we just did the other one, right? The last question. Find the sum of first 15 multiples of 8. So 8, right? So we are simply going to go 8 1s are 8. So it's the table of 8, right? 8 2s are 16. So we're going to just do a few. So it will be 8, then 16, then 24, then 32, so on and so forth. So this is going to go on, and we are going to find out the sum of first 15. First 15. So it's S15 will be this plus this plus this. We don't know, what is the last term. So I just wanted to show you maybe one other way. In the last question, we solved it in one particular way. The other thing you could have done is you could have said, well, let's find out the 15th term, or let's find out the last term. So in the previous question, we wanted to find out the sum of first 40 terms. So here it is 15 terms. So why don't we find out the 15th term? So the 15th term will be A plus N minus 1 times D, correct? The fact that we have figured out that this is actually an arithmetic progression, so we know that A is equal to 8 for this question, and D is also equal to 8, right? So if we want to find out the 15th term, so 15th term, A15, will be equal to A is 8 plus 15 minus 1 times 8, right? So, or if you take 8 common, it will be 1 plus 15 minus 1. Plus minus will cancel out. So 15 times 8 is 120. So in other words, the 15th term, if you find out the 15th term or the last term, like the way we did it, then we can say the sum of the first 15 terms is n by 2 times the first term plus the 15th term. So just wanted to show you a little bit different way of solving the very same question, similar question. So in this case, n is really 15, right? So this will be 15 divided by 2 times the first term is 8. The last term, which is 15th term, is 120. So if we just simply solve this, you're going to find out the value of, or you're going to find out the value for the first 15, sum of first 15 terms. So this will be 138, no, it will be 128, right? So it will be 128 by 2. Clearly this and this will cancel out. It will be 64. So 15 times 64, whatever the value is, I will leave it up to all you smart people out there. So this is going to be the answer for the sum of first 15 terms of this arithmetic progression. Let's take a look at maybe one last question before we wrap up this presentation. Find the sum of odd numbers between 0 and 50. This is a super interesting question because it's a really straightforward question. Find the sum of odd numbers between 0 and 50. So whenever you get these kinds of questions, right, this question or the last few questions, you want to first try and write out the numbers, at least try to write out the first 3 numbers, and then see what is the pattern, if any, in these numbers. So we know the odd numbers are, what are the odd numbers? 1, 3, 5, 7, so on and so forth, right? And so if what we have to do now is we have to find out the sum of this plus this plus this up to 50 terms. So the interesting thing is, whenever you write these numbers out, you realize they are in arithmetic progression indeed, with the first number equals 1. And what is the common difference? Let's take 5 and subtract 3 from it. Obviously we know that odd numbers, they have the gap of 2 numbers, right? So there are 2 numbers from the last number, which is the same for even numbers too. It's just they have a different starting point, right? For odd numbers we start at 1, then 1, 3, 5, so on. If it were even number, we'll start, we'll have 2, 4, 6, 8 like that, right? So what we have is, we know the value of A, we know the value of D, which is 2, and we also know that we have to find out n equals 50 for the first 50. Actually this is wrong, I made a mistake here. Between 0 and 50 we don't know n. This is interesting. So we don't know n. I assumed it was for the first 50 odd numbers, so it was a mistake. This is not given as 50. So what is given is between 0 and 50. That means the last term will be what? It will be, what is the greatest odd number less than 50? Clearly that is 49. Right? So we start 1 plus 3 plus 5 plus 7 dot 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 plus 49. So what is given is, let's assume there are n such numbers. Then nth term should be equal to first term A plus n minus 1 times D. So from here what we can find out is A is the first term 1 plus n minus 1, we have nth term, times D, common difference is 2. Now nth term for us is equal to 49. Equal to 49. Or from here if we solve this, we will have n, so this will be So let's do one thing. So this plus 1 will go on the other side, will become 48, and we can divide 48 by 2, right? So we can write n equals, so this one will go on the other side, 49 minus 1 is 48. So at that point divided by 2, and whatever the value we get, we will add this minus 1. So it will go the other side, it will become plus 1. So 2 4s are 2 2s are 4, 2 4s are 8. So 2 2s are 2 4s are plus 1. So this will cancel out as 24. That means this is equal to 25. So what we did, we have to actually first find out how many such terms are in this. And we found out there are 25 terms. Using this formula, the nth term equals a plus n minus 1 times t, we found out there are 25 terms. Now that we have found out there are 25 terms, so the sum of these 25 terms will be simply n by 2 times, we will use the first term and the last term, 25th term, and we know that is 49. So we will say n is 25 divided by 2 times the first term is 1 plus last term is 49. Or in other words, this will be 25 by 2 times, this one will be 50, and this will be 25, or 25 square is 625. That means the sum of odd numbers between 0 and 50 is 625. So again, friends, like I was talking about earlier, when we were looking at, all the 2-digit numbers divisible by 3, or all 3-digit numbers divisible by 7, or anything like that. The same thing here. Look how such general questions, we can interpret them as arithmetic progression, and then using the formulas of arithmetic progression, that is the nth term is a plus n minus 1 times d, and using the formula for the sum of first n terms, n by 2 times a1 plus an, or n by 2 times 2a plus n minus 1 times d, how using these two formulas of arithmetic progression, we can solve these kinds of very open-ended questions.